Hey everybody, thanks for coming. So, before we get started, I have a job for all of you during this talk. I was giving Kevin and Jeff and Olivia a hard time when the lineup came out for the talks today. I said next year, when we do the lineup for Droidcon, if it's going to be on Football Sunday again, we've got to cross-reference the city that all the presenters are from with the time slot for their talk and the games that are actually occurring that day. So it just so happens that the Eagles and Redskins are playing right now. It looks like they're coming up on halftime though, but your job is, if anybody scores during the duration of this talk, just shout it out. I don't care if I'm in the middle of the most interesting point, just let me know. So my name is Chuck, and I'm an Android developer at a company called MapZen here in New York. And we are an open source mapping lab. And so what does that mean? We work on geospatial tools for building open location applications on both web and mobile. And really, the work that we do is kind of guided by two rules that we have. Number one, all of the code that we write has to be open. And I would add to that kind of rule 1A is that whenever possible, we try to use open source libraries as well in our projects. And then rule number 2 is that all the data that we use also has to be open. So publicly available, freely available data is what our projects are based on. I think if you wanted to play, turn this presentation into a drinking game, I would say open would be the key word here if everybody wanted to drink a lot. So, start where you are. This is really more of a guiding principle to the work that we do rather than a hard and fast rule. But essentially it means, you know, things might not be perfect, or you might have this tendency to want to wait for like the big reveal of like having something fully built and fully implemented and ready for prime time, and then, you know, and that keeps getting pushed back further and further and further because there's always just that one more thing you want to cram in before you share it with everybody. Well, operating 100% in the open, we don't really have that luxury. I mean, all of our stuff is on GitHub, it's all public, anybody can look at it. Anybody can comment on it, contribute to it, use it in their own way. And so we just kind of have to have this approach of recognizing where we're at and figuring out what the path is forward, and doing that in kind of a collaborative and open way. Does anybody know the name of this drum? No? So this is called the djembe. And
I'm big into fantasy football. That's why I got DirecTV NFL Sunday Ticket. They got a new channel that's...
I knew this was going to backfire on me. All right, here we go. So the djembe comes from West Africa, and basically it's a hollowed out log, one solid piece of wood with some sort of animal skin stretched across the top of it, and then some sort of system to provide tension. This particular one has ropes on it. Touchdown who? What? All right. Okay. We got time. So the djembe comes from West Africa, and here is, so that first one was more of an old-fashioned example of, you know, kind of a historical one. This is more of a modern example of it. Maybe you've seen them around. And then there's also another set of drums that goes with the djembe called the dunun. So all these drums are dunun, and they have skins on both sides instead of one side, and they're usually played with a stick. And this picture doesn't show it, but a lot of times they have a bell on top as well. And so you'll play the bell with one hand and the drum with a stick in your other hand. And then actually these three drums each have their own individual names. The smallest one is the kinkani, the medium-sized drum is called the sangban, and the largest one is called the dunumba. In the Malinke language from West Africa, where this music originates, ba means big. And so dunumba is simply the biggest dunun of the family, but collectively they're known as the dunun. And so I got first introduced to traditional African music when I was in college. I went to Penn State in central Pennsylvania at University Park, and we were fortunate to have a club there that did traditional African drum and dance. And I had played other types of percussion growing up, but the first time I saw this music, something for me just clicked, and I was like, that's what I need to be doing. So I started going out to the rehearsals and playing for the different classes that they had, and then eventually performing with the group as well, and it was something I did all the way through college. This picture's from 1999. That's me, all the way on the right. You like the hat, don't you? So this was from right before a concert that we did, and this was in my senior year, and so I had been playing for 3 or 4 years at this point. And we all felt like we had a pretty good understanding of this music. We felt like we knew what was going on. We were relatively experienced and you know, could play some of the more complex rhythms and felt pretty good about ourselves, right? Actually, one of the things that originally attracted me to this style of music is the complexity of it. So you're playing in like timings that don't really, like the Western ear, our music isn't really trained to listen for some of the time signatures that this type of music gets played in. And so we went into this concert, and this was kind of like our crown performance before we graduated and whatnot. And then a few years later, fortunately, I had an opportunity to take a trip to West Africa. And I encountered drummers like this. And I said, whoa, I don't really know what I'm doing. And these guys were just playing on a whole other level, right? It kind of blew me away. Here's another picture. This is more of a casual setting, not a performance, but just because it's more of a casual environment doesn't mean the music had any less force. And just to give you an idea, because words don't really do it justice, I'm going to play a little clip here for you. As soon as we get to the advertisement.
I got something to tell you.
So powerful.
Yeah, I think powerful is an understatement. So for me, having been playing this music for a few years, and thinking I knew what was going on, and thinking I had mastered these complex rhythms, I got there and I realized I didn't really know anything. And so this was kind of like a pivotal moment for me as a musician, where I was like, okay, I could either, the thought went through my head of like, I'm never going to be able to achieve this level, I might as well just quit now. Why continue going, right? And I was constantly comparing myself to the other musicians that I saw there. But it really forced me to kind of adopt this mindset of, well, what's the next step forward? Now that I know where I'm at, what is the next step that I need to take in order to improve? Start where you are. Okay, so building location-aware apps with open source and open data. This is kind of a broad topic, and really what I think is going to work the best here is if we break it down into a few different sections. So the first thing I'm going to talk about is simply location-aware apps. Just so I mean, everybody's familiar with them, but I want to make sure that we're all on the same page about the types of things that go into building a location-aware app. So location-aware apps, for me, I really, this breaks down.
When I had cable, I only got some of the games.
Alright, sorry about that. Hopefully this is not going to pop up again. So for me, it really breaks down to 3 different types of location-aware apps. The first one would be full-on mapping applications. This is really apps that are centered around the map, and that is the primary component of the app. Number 2 is location-based apps. So these are applications that are built primarily around location-based features, but not necessarily, the app isn't really the central, or I'm sorry, the map isn't the central component, but it can be one of the components that goes into making the app. And then the last one for me is apps that just take advantage of location to kind of enrich some of the features that they offer to you, but it isn't really the primary purpose of the app. So now we're going to look at a few examples of location-aware apps. Here's a popular one, maybe you've seen it before. It's called Google Maps. So this is one, obviously, in many ways is the gold standard for mapping applications on Android, and obviously it's a full-on mapping application. Another example of this would be MapQuest. Or even I would put Waze into this category because even though it's a little bit more specialized, it's still, the app is built around the map. So here's another example. All right, I've got to fix this once and for all, you guys. I apologize. Boom. That's it. All right. So here's another example, and now we put this into the second category, Foursquare. So not necessarily built around the map, but obviously the entire application is thoroughly enriched with location. That's really kind of the primary purpose. And as you dig into a particular location, you can see the map down here in the corner, which you can expand to go full screen, but not necessarily everything is going to be on the map. Another example of this category I would say is Zillow, a real estate application where you can look for houses and then you can also place them on a map. This is a picture of Cape May in southern New Jersey. Really nice area, and it looks like home prices are incredibly affordable compared to New York. And then the last category is going to be applications that just kind of take advantage of location to enrich the other things that they're doing. So I would put Google Now into this category. As you can see in this view here, it's using your current location to decide which weather to display to you, which city's weather, and then also to show you some places nearby of interest. But location isn't necessarily the front and foremost reason for Google Now. There's lots of other things that it does as well. And here's my last example. This is an app I helped build a few years ago called How About We. Essentially, it's a dating application, but instead of being built around profiles, it's built around the actual dates that you would like to go on. And so that's why you see in the list here, like, how about we take a dance class? And as you can imagine, it would be rather difficult to go on a date with somebody on the other side of the country, or the other side of the world for that matter. And so the default sorting is for people who are in close proximity to you. And so that's another example of taking advantage of location to enhance an otherwise not necessarily location-centric application. Okay, so let's take a look at the second piece of our thesis here, which is the open source component. So first and foremost, to me, I would say open source is a philosophy. It's an approach to doing development. It's an approach to building products and tools. And it kind of tends to go throughout the, it's something that you have to think of when you're going into it, and it's something that you have to think of throughout the life cycle of the project. As open source implies, if you don't have the code, then it's not really source. So obviously this is a key component to an open source project. But really that's not enough. A lot of open source is about the license as well. If you put something out there without a license, you might think it's open source, but it isn't really, because a lot of times it's going to default to copyright, and that also leaves kind of a vacuum where people aren't quite sure what rules they can use or not use this project under. So it's always best to have an explicit license included in an open source project. And then I would say the last component is community, which without community, you're kind of just somebody writing some code that happens to be on the internet. But really, I think a true open source project is built around the community that it attracts and that helps maintain it and that kind of drives its evolution. So real quick, I want to touch on a few of what I see as the advantages of open source. One would be transparency. So the fact that you can crack open the code allows you to do things like it makes debugging easier, it alleviates any doubt about exactly how the internals of this library, or this project or this app that you're using behave, and it allows you to even modify or change the behavior in some instances, which brings me to my second point, which is flexibility. The flexibility that you get with an open source project is really valuable in the sense that if it's not doing what you want it to do, you can change it. And in a best case scenario, you can even, if you think other people would find these changes useful, you can contribute back to the project. Thirdly, I would say compatibility. So especially when you're talking about in the Android ecosystem, compatibility is kind of a big deal, because if you can package up this code or include this dependency in your project, then you can really run that in any variation of Android. Whereas if you're using something that's proprietary that only exists on certain versions of the platform, then that's what you're going to run into issues if you want to launch into more than one different ecosystem. For example, Google Play versus Amazon versus something else. And then the last one, probably the one that attracts a lot of people to open source, is the fact as well, it's free, right? But this kind of comes with a footnote. So I like to say open source is not free like beer. Rather, open source is free like a puppy. Don't ever let anybody tell you that a pet is free, okay? Because there's a lot of other costs and time that comes with that endeavor that might not necessarily be represented up front. And it's similar with open source projects. So you're going to be investing time to maintain, to learn, to take advantage of the project in the best way. And it's not just the kind of thing where you just drop it in and forget about it. And this even speaks back to the community aspect of open source. As a side note, why does the Android emoji for a puppy look so much like a bear? Can anybody tell me that? All right, so now let's look at the last component of our thesis here, which is the open data portion. Open data to me is defined by availability and access, and actually this isn't even just coming from me. I'm going to show you a reference at the end here. And so it's the idea that everybody, the data is freely available to anyone who's interested, and there are reasonable means to access it. Reuse and redistribution, this is a key component to the concept of open data, and that is you have the rights to reuse this data. You also have the rights to distribute it to other people. And then finally, universal participation, which is the idea that everyone should have equal access to the data. You shouldn't have to be a member of a club, or there shouldn't be any like quid pro quo trade-offs to get access. If you're going to make it available to one individual, you have to make it available equally to everyone. And this is coming from the Open Knowledge Foundation. There's a link here if you would like to learn more of the details about the open data movement. Okay. So now let's take these three pieces and start to synthesize them all together and really talk about what goes into building an Android application that's built around open location. So I think there's some key components here that kind of tie all this together that you're really going to need to consider if you want to build an app based on open location. And the first one would be a data source. So you need some repository, some vehicle to get your data to your application. The second one would be vector tiles. Now this is specifically if you're going the route of mapping, you need a way to format that data into tiles that then you can turn into a map. The third one I would say is a renderer, and this goes along the mapping route as well. So this is taking that data that you have in your vector tiles and actually turning it into something that you can display on the screen. A lot of times this is going to be, on Android, we're going to be using OpenGL for this, and because that's just going to be more performant than any other solution. Location services, okay, so now that we have all this data, we have these maps and we can put things together, well, it's really helpful to know where the user is, where the device is, and so this is really talking about things like GPS, network, whether it be cellular network or Wi-Fi, and then also kind of the new kid on the block is Bluetooth Low Energy, which allows you to do positioning specifically relative to beacons. Another key component is a geocoder for a lot of location-based apps, and so what this is a tool that allows you to convert a physical address to a lat long, and then reverse geocoding would be going the opposite direction, taking a lat long and figuring out what is the closest physical address, geographic representation of that. The ability to do searches based on location and geography is really important. And finally, if you want to do any sort of navigation or routing, you need some sort of route engine to compute that information. So now what I want to do is dive into some specific tools and specific examples of services or libraries or applications, well, no, not applications, but services, libraries, and SDKs that are going to help us build open location applications on Android. Okay, so the first one I want to talk about is OpenStreetMap. How many people are familiar with OpenStreetMap? Okay, about half. All right, so I'll go into medium depth on this. But really, if you're not familiar, probably the best way to describe OpenStreetMap is as the Wikipedia of location and map data. So a lot of the data for OpenStreetMap, actually the primary source of the data is crowdsourcing. And so really they put a lot of emphasis on local knowledge and community-driven data initiatives. There's also a large public data component to OpenStreetMap, and a good portion of this is coming from one massive automated import that happened back in 2007 of Tiger data, which is tied to the US Census. And to make a long story short, this process was kind of an ordeal, and the OpenStreetMap community is still dealing with the ramifications to today, because not all the data was 100% accurate, and the process wasn't 100% smooth. And so a lot of times you have old Tiger data in OpenStreetMap that isn't accurate. And so now there's a manual process to update that, and then really the consensus in the community is we never want to do that again. We want to only have data added in more of a manual fashion so that we don't get into this same type of situation again. And then OpenStreetMap it's under its own license, which is known as the Open Data Commons Open Database License. It's kind of a mouthful. But essentially it boils down to three things. If you want to reuse the data and represent it in a visual way, you have to give attribution to OpenStreetMap on there. The second point here, share alike, is probably the most controversial one. Because essentially what this means is if you want to use OpenStreetMap data, but you have some additional data you want to add to it for your specific application, then you are also obligated to open up your data that you're adding to it. And so this gets into a kind of a difficult area, especially for a lot of government applications or proprietary applications where they're just not in a position where they want to take advantage of OpenStreetMap, and but they have something they want to add to it, and they can't necessarily open up that additive piece of data. And so that leads to kind of a difficult relationship at times. And then the last one is, if you're going to use it, you should keep it open. You shouldn't take OpenStreetMap data and then put it in your app and lock your app under DRM. Or if you do, you need to make an open version of it available. This is a screenshot of the OpenStreetMap website, but the important thing to realize here is that OpenStreetMap this is simply one visual representation of it. It's really about the data that's underneath, and you can make any number of visual representations. So the next project I want to talk about is OSM Droid, and it started back in 2008, so this really makes it kind of like the grandfather of all open mapping initiatives on the Android platform. And so it's an SDK to do OpenStreetMap visualizations on Android. It's based on the original Google Maps API v1, so MapView. And one of the kind of value adds that it came with when it originally launched is the support for online and offline tile sources. So you could actually package some data into your app, and you would have that available in an offline fashion. And then you could also do things with overlays like icons, tracking, and shapes, the kind of things you would expect to see from a modern digital mapping application. And here's an example of what their demo app looks like. The next tool I want to talk about is Mapbox. And the Mapbox Android SDK is based on a fork of OSM Droid, but it's significantly evolved from that point, and so there's been a lot of changes since then, and it's kind of evolved into its own thing. Now, kind of the key aspect of Mapbox, or one of the key aspects, is that it provides really easy integration with Mapbox's tile servers. So their business model, Mapbox, is built around essentially a hosting service where you can put your mapping data and you can do some styling and customization to it server side, and then serve it up to your app in a straightforward fashion. So you can see the example here of including a Mapbox map view. You simply plug in your ID for your server-side map that's pre-styled, customized with the data that you want, and it will load that up for you in your app on demand. And you can also do the same thing in Java code if you don't want to do it in XML. Now, I did find in the fine print somewhere on Mapbox's website that alternate tile servers are also supported besides theirs, but I didn't find a whole lot of documentation and examples about this particular use case. But then again, if I had a business that was built around hosting, I probably wouldn't advertise ways to get around that front and foremost. But they are doing a lot of great things in the realm of open source rendering and development on Android, and that shouldn't be discounted because they have a proprietary hosting service on the back end. And so another nice value add that you have is you can do a lot of custom styling, and they also have some satellite imagery that's really nice, that's based on NASA data. that you can use in your map or in your applications as well. And here's an example of what their sample app looks like. So the next project I want to talk about is called Open Science Map. And this is a research project coming out of a university in Germany, the University of Bremen. And essentially the stated goal of it, well, I'll give you a quote right from their website. Open Science Map provides free and open maps for Android with the fastest and 100% pure vector maps around. So this is really a good summary of the goal of the project. So they have their own tile server that serves up OpenStreetMap data, and then they also have an Android library client that consumes that data, and really their goal is to just render that data as cleanly and as fastly as possible on Android. So similarly, you can include a map view here. You don't have to tie it to any specific ID because there's going to be more configuration that happens on the Java side here. And more of the custom, so the way that Open Science Map is built, as opposed to having a lot of the customization done server side, is you're going to be doing your customization and your styling client side. Another thing that's recommended with the Open Science Map project is to have your activity extend their map activity. And this is, I mean, it's slightly unfortunate because if you have like a base class you want all your activities to extend from, this kind of makes it difficult. There's probably a way to get around this, but I haven't used it in particular, so this is one way to do it. And then you do get some advantages from extending map activity, like it hooks up the map view to your activity automatically for you. And so you can do things like grab the reference to the map and make calls to the map without actually having to find the view and do all that wiring yourself. And so here's where we can get into some of the customization. So firstly, the thing that you want to do when you're using Open Science Map is to hook up to your tile server. And so this could be theirs, which they make publicly available, or it could be one of your own choosing. And so you create the tile source object, and then you set that on as the base layer of your map. And then, so the customization comes in the layers that you decide to show. And so, for example, here we're adding a building layer, we're adding a point of interest layer, and then also a lot of the power comes in the ability to set the rendering theme client side, and so you can include these XML style sheets in your app, and you can change the theme on the fly of how it's rendered. So you can have, you know, one, so say you're doing navigation, you can have one that's set up for driving that really makes highways prominent, and then you could have another one that's set up for walking, which you know, puts highways in the background and puts emphasis on things like footpaths. So there's a lot of different applications that you can think of for this, and that's really one of the neat features of Open Science Map. And here's what their demo application looks like. So the last thing I want to talk about here is a couple of the tools we've been working on in MapSend. So the first one is called Peleus, and Peleus is a new open source geocoder we've been working on that also supports full text search. It's built on top of Elasticsearch, and this is a back-end service. The initial version was written in Rails, but we're working on a new version that's under development that's based on Node. And you can set up. We have an instance of this that's publicly available for testing against. You can also set up your own instance of Peleus to run on your own hardware if you want exclusive access to it. And really, so there's also an Android SDK that we built that wraps up the networking calls for you and provides a nice interface inside of your Android app. And so you can do things like autocomplete. So if you are typing in a location or a point of interest or an address, you can send that off to Peleus and it'll give you a list of suggestions of places that match it. You can also do a search on a specific area. So the middle argument here for the second example, the X1, Y1, this is a bounding box that shows the geographical area that you'd like to search inside of for that given piece of text. You can also search based on a lat long. So it does geocoding and reverse geocoding. And under the hood, it's using retrofit as the actual networking service. So we have retrofit style callbacks inside of there that then come back into your application with either your results or your error. Another project we've been working on is called On the Road. And On the Road is a client-side library for Android to do navigation and routing. And it also, the back end for On the Road is based on a project called OSRM, which stands for the Open Source Routing Machine. And so On the Road makes calls out to the open source routing machine to get directions from point A to point B or via other points along the way. And then you get back this list of directions or this route from the open source routing machine. And then what On the Road does is it helps you kind of maintain that route and navigate the user through it. So it does things like taking in your location and snapping it to the directions. Because when you're navigating, if you're getting locations that are slightly to the, off to the side of the road, when you're in a navigation context, you really want to see yourself on that route if you're anywhere close to it, unless you're obviously lost, and it helps you do things like that. Detect when you're no longer in proximity to any portion of the route, reroute you, things like this. This is what a call to using On the Road looks like. So we have this concept of a router and a route, and the router is the thing that's sort of like the builder that helps you put together the request to get your route. So you can set an endpoint on there wherever your OSRM instance is at. You can set your mode of transportation, whether it's driving or walking or biking. You can set locations. If you do 2, it's considered the start and the end point. If you have additional ones in there, those would be your via points along the way. And then you set a callback object on there that returns with your route if it's a success, and if not, you get some sort of failure code. And then fetch simply spawns the background process to go out, make the network call, and then asynchronously returns to your callback. And the last specific project that I want to talk about that we've been working on is known as the Location Open Source Tracker, or as we affectionately like to refer to it, LOST. So, going back to point 1A from, rule 1A from when I introduced MapZen, so we try to make sure that all the libraries we use in our projects are open source. And so that means that on Android, we don't necessarily have access to, or can't assume we're going to have access to Google Play services. And so we built this library essentially as a drop-in replacement for the location client that comes from Google Play services. So the nice fused location provider that looks at passive and GPS and network and figures out which is the most accurate at that time and does optimizations for power consumption. That's what LOST is looking to do outside of the Google Play context. And this code should look really familiar because the API is basically the Google Play location client, which makes it a drop-in replacement. The one thing that we intentionally left out is the concept of failure listener when you're attempting to connect, because there's really no need for that, considering that usually returns if Play Services isn't available, or your version's outdated, or the user's not signed into the Play Store. So we didn't really need that, but otherwise the actual calls you make to get location updates, to register for updates, to get the last location, it's modeled after the same API. So in this example here, when the location client connects, we can grab the last location that was stored by the location manager. If that's available, we can do something with it. Then we can also set up a request here with an interval of every 5 seconds. We'd like to receive an updated location. And then we'll get a call back from that, that we could also do more stuff with that. So we've also been working on an app that kind of showcases how you can tie together these different pieces. And really the emphasis isn't on the map as much as it is, or on the app as much as it is on the different libraries and showing how they can interact with each other. And probably the best way to illustrate this is with an architecture diagram. So we have our demo app up at the top here, and then underneath of that are the primary libraries we're using to put it together. So we're using OpenScienceMap right now as our renderer that I spoke about previously. The library that they use for rendering on Android is actually called VTM for Vector Tile Maps. We're using our Peleus Android SDK, On the Road, LOST, and then SpeakerBox is another little micro library that we threw together, which basically wraps up the text-to-speech engine on Android that we use inside of navigation. It kind of gives it a little bit of a nicer API and some utilities that otherwise we found ourselves writing over and over again. And then, so down on that bottom layer there, what you see in orange is our remote services. So we have our data source that serves up the tiles. We have our instance of Peleus running server side, and we have the open source routing machine, which we've also made some contributions to, but it's not our original project. And then what you see in dark green is parts of the Android framework or the system, like OpenGL, where we get rendering, the location manager, which is what's really, behind the driving force behind location, and the text-to-speech engine. So here's a screenshot of what it looks like when you fire up the app. This is centering right now somewhere in Chelsea. I believe this is at our hotel. And here's the search view. So searching for Empire State Building shows you a pin on the map. This information is coming back from Peleus. You zoom in, you get really nice. New York has really nice building data because the city released it a while back, and so that's all been incorporated to OpenStreetMap. So as you zoom in, you get all the nice three-dimensional contours there. Here's what it looks like in route preview mode. So say, okay, now route me from my hotel on 26th Street up to the Empire State Building, and this is what we get. And then if you click on that start button, this is what it actually looks like in the active routing mode. Now, we realize that there's a lot of work to do, and that really, all this code's available on GitHub. If you go to github.com/mapzen, you'll find all our projects. Actually, a few of them, we started giving them their own organizations. Like Peleus is big enough now that has its own organization on GitHub. So that's github.com/Peleus. We have a lot of work to do. Most of these libraries are still in dot releases, so 0.1, 0.2, 0.3, and you'll see that there's gaps in the functionality and specific use cases that aren't quite handled yet. But we felt like we're nearing a point where we wanted to share this with the community and start getting feedback, start getting input, maybe start getting some collaborators on it, because that's kind of like the stated goal of our project. And besides, start where you are. So in that video clip we showed at the beginning, the drummer who actually came out and danced at the one point, his name is Lansai Kante, and he was the Dunum player for the National Percussion Ensemble in Guinea. Throughout the 60s, 70s, and 80s, they toured all over the world and was really at the forefront of them promoting their cultural arts to the rest of the world in the post-colonial era. And so, while I was there, I managed to kind of forge a relationship with Lansai. He became my teacher. And so for a period of 5 or 6 years, I went back every year and spent a month or two in Guinea studying with him and learning more about the music, learning more about the Malinke tradition. A lot of the rhythms themselves, the reason it was so hard for us to comprehend was because the music is actually based on the language. And so when you're playing the drum, you're actually speaking the Malinke language and saying certain words and phrases out of it. Which again, not only is the timing totally different than what I've ever heard, but the language is totally different than anything we had ever heard before. And so I still play today. I play with a group in and around Philadelphia, and we'll do, we play for various dance classes and festivals. And this shot here is from a theater production we did a couple of years ago called Village, an Afro-futuristic fable. And so it's still a big component of my life, and I play whenever I can find time to do it. So thank you very much for coming and listening to my stories, and maybe I should say in the Malinke language, Inike. And so it looks like, I know we're up against the break here, we have just a couple minutes for questions, if there are any. Yeah, right here.
Do you know if there is anybody who publishes the data about the location of the cell phone towers that the phones are talking to? I mean, the phone always knows where you are, and it's annoying that you have to use GPS and worry about the battery drain and whatnot.
Right, so the question is about the physical location of cell phone towers and kind of, is that data published? So the network, the cellular network location data is actually the least reliable of all the sources, it's the least accurate. So I'm sure that the physical location is a component of how they kind of triangulate where you're at, but it's still going to, like compared to Wi-Fi or GPS, it's still going to be way less accurate than anything you can get from those two. As far as who publishes the data and where it's available, I don't know the specifics on that. Yes?
So let's say you were building an app that required data on whole lot of buildings, every building in the United States, right? What's the best, I guess, open source solution for doing so, or is there?
It varies. So, for example, the New York building data was released by the city, but it had been already imported into OpenStreetMap. So OpenStreetMap would be my first recommendation. That's where I would look. If it's not available there, you might check with the local governments or local organizations that might have access to that type of thing. Yes, Kevin?
Maybe not the most interesting thing, but I'm a little confused by the share-alike part of OpenStreetMap. So, for example, let's say you're Trulia and you're putting these 10 houses are for sale. Does that count as data that you need to share back, or is it only like this road is incorrect in OpenStreetMap? It actually goes, northeast. I need to share that data back if I figure that out.
Right. So that gets into more of the details of kind of what is covered under there.
Yeah.
And so OpenStreetMap is really specific about the type of data that's included. There's even a big debate about something like traffic or driving times and whether or not that should be part of the OpenStreetMap data. And so actually, right now, those tags aren't included. And so if you add, like, say, average driving time between here and there, because it's not something that OpenStreetMap supports right now, then it's not covered by the share alike, from my understanding. So I would say that if you're Trulia, for example, OpenStreetMap isn't in the business of, or not the business, their stated goal isn't real estate data and housing prices, so that's not something you'd be obligated to contribute back. But if it's something that they actively work on, like roads, like buildings, that type of stuff, points of interest, then share alike will kick in at that point. And that's my best understanding. I'm not a legal expert.
Yeah.
So we are at time now. I will take any other questions downstairs in the coffee line. But before you go, I have my assistant here with me today, Annika, my daughter, and she's got really cool Maps and stickers we just had made. So if you'd like to get one, come see her. Thanks, everybody.